My name is Ruben Moit, founder and CEO of 3D Spark, and I'm very happy that Ignacio Casanova from ZF Friedrichshafen is joining me today to talk about democratizing AM at ZF. Also very interesting presentation before, I think, with the damping system. I think that is one of your largest, you're one of the largest producers of these systems, right?
Our current business right now.
Yeah.
Can you hear me? Yeah.
No, it seems to be off. Okay. What we're going to do is, first of all, I am going to give a little introduction on 3D Spark, what the software actually does. And after that, Ignacio is going to take over and speak about how ZF is leveraging the software and embedding it in their current software and process landscape. Well, first of all, what 3D Spark actually does is we are building the Google Maps for manufacturing. What that means is it's a software, a web-based software. You can put in product data, then the software analyzes thousands of production options and then shows you the cheapest, the quickest, and the most sustainable way to produce the part. And we believe that this is actually really important of a problem to solve, because imagine out of the hundreds of millions of parts that are being produced every day, and imagine there are just some parts that could be produced in a more efficient way, and it's simply not done because the knowledge was not there that there's a more efficient way to do it, right? So this means a lot of waste being created in production. We don't like that, and this is why we give this transparency with the software. On a daily level, this means that this kind of solution is needed for two applications, basically. Number one being production and sales of parts, and the other one is actually procurement. Looking at the sales side of it, we see that, for example, manufacturing service providers or 3D print shops, for example, they receive quotes, RFQs every day, so requests for quotation. And they see that the quoting process is an absolute bottleneck for them, which means losing revenue. Because what does the industry standard process look like today? It's what you see here, right? So there are a lot of different software tools that are needed to create a quote. Every time you switch from one software to the other, there's a potential risk of errors, obviously. Typically, more than 4 software tools are used for the quoting, and the quoting time that is needed is typically more than 30 minutes, can easily go up to 4 hours. So really a lot of cost that is incurred here, actually. Depending on how many quotes are created, this means there are easily costs more than 60,000, hundreds of thousands for simply creating PDF documents, basically. Now, typically, more than one person is involved in creating the quote, typically a sales rep, then there are application engineers, technology experts, and thirdly, sometimes even controlling. So then for every handover between people, this means waiting, right? Waiting for an answer, people go on holiday, they get sick, and so the answering time is typically more than 24 hours, easily a week. And this has a direct impact on the win rate of an RFQ. And when looking, for example, at a win rate of 5%, this means 95% of the created quotes are without ROI, right? So this is very inefficient and has potential for improvement, obviously. Then looking at the procurement side of it, for especially large organizations like ZF, for example, or Alstom, world's largest train manufacturer, they have the same process which I just described when they get requests from their suppliers like Deutsche Bahn or ÖBB, for example. But on top of that, they do a lot of make or buy decisions. So they also subcontract to suppliers, which means they need to send RFQs, wait for the quote to come in before they can make this decision. That's unscalable. Secondly, with a lot of employees, a lot of sites worldwide, there's like an internal marketplace. So other colleagues requesting parts, spare parts, for example, and also this needs to be analyzed and answered. So this is also not scalable And to make it scalable, they are using 3D Spark software. As described in the beginning very briefly, it's a web-based solution, so it runs on any system. And the inputs are 3D CAD files, 2D documents, especially technical drawings and specifications, for example, metadata. And then what happens is an analysis is performed on the production reality of the respective customer. So not a general thing, but a digital twin of the factory of ZF, for example. So that is the one focus part, actually. And secondly, also qualified suppliers may be connected, which then allows to get instant price indication feedback. So with that, this helps with the make or buy decision, and then you can forward RFQs. But I'm getting ahead of myself. So, okay. What are the outputs then? Manufacturability assurance for every production option. Can it be produced, yes or no? Technology comparison between the technologies that are looked at. Very precise make costing, and then comparing that to the market prices, and a CO2 footprint calculation as well. So with that, all of the 4 main decision pillars are available: cost, quality, time, and sustainability, to make good decisions in the manufacturing and procurement of parts. And with that, this now enables, obviously, smarter make or buy decisions. It then allows, if the decision goes towards selling the part, to select one in-house production option and then generate a quote, auto-quoting. Or if it is the decision is towards buying, to select the qualified connected supplier and with one click forward the RFQ. And lastly, by performing these tasks, automatically a lot of information is gathered. Basically, organically, a digital warehouse is being built up. And KPIs like cost, lead time, and CO2 savings are gathered, which help a lot with management reporting. So that was on the high level. Looking at the time, going to jump quickly over the details. For every machine material combination, there are a lot of different manufacturability checks that are performed. Then when looking at the core of the costing, the make costing, it's important to see that all industrially relevant AM technologies are included regarding metal, polymer, and ceramics, but also more and more conventional technologies like rapid casting, injection molding, milling, etc. And we're building more and more to really build this Google Maps for manufacturing. Also important, the calculation is always done on the process chain level, bottom up. So this means it's not a black box, but it can be 100% benchmarked to the production reality, and therefore accuracy can be proven. And as you see, these numbers, the labor time and the machine time estimations, etc. For this, we leverage advanced algorithms like orientation optimizations, nesting optimizations, etc. And this then allows to provide these kind of break-even analysis where you really see all of the in-house production options in which makes sense in which case. As said, there's also a CO2 footprint calculation. It's a cradle-to-gate calculation. Could go a lot more into detail about that. With all of this as a backbone, basically, this now allows also to provide a so-called part request portal. This is like a super light version of the software, specially designed for non-experts, which allows Ignacio, for example, to scale AM internally via single sign-on. Everybody can access it and easily request quotes on a self-service level. The same portal can be used by manufacturing service providers to put that onto their website to actually turn then website visitors into paying customers. The second point I briefly touched upon is talked a lot about the production side. It also has the My Suppliers side, which is like a supplier panel where you list your qualified suppliers to get live price indications and forward RFQs with one click. And this is obviously also interesting from supplier side to receive targeted RFQs with native complete data. Very quickly, the software works as is proven by our customers. On the service provider side, we see that it allows to generate 10 times more quotes in the same time, so really improving efficiency. It saves actual costs, and especially when using this website integration, the answering time is instant, so it's much quicker, which really leads to a higher win rate, higher ordering rate. So more business won, which is what it's all about. And on OEM side, we especially see this leveraging effect, 200 plus users, for example, at Alstom, to democratize AM internally. What Ignacio is now going to talk about, very much successful in application, the software in the mobility sector, especially rail, but also automotive. And that's the hand over to you, Ignacio.
Thank you. I think, yeah, you can hear me perfect. So I am not used to speak to the microphone. I have to get used. So Ignacio Loba is my name. I am working for ZF and leading the department for additive manufacturing. So we start the cooperation with 3D Spark some years ago. We have some problems, as Ruben was telling you. That is the amount of requests from colleagues that they are looking for a prototype, for a tooling, for a jig is increasing almost every day. And in the past, we were working every day with emails, with phone calls, asking, is this part printable? What are the costs of this part? And we needed to improve this process. For this reason, we get in contact with Ruben, and then we started a pilot project within ZF to test the 3D Spark tool, and then to check the manufacturability of the parts, to have a rough quotation in the beginning, how is the cost of the part when we want to print in different technologies, and later on to have one assessment, what should be changed in the part in terms of design to make it feasible. As you can see here, there are some screenshots from a bale block. It was something discussed in the last presentation. We have the standard design for the bale block. The guys from the controlling in the past, they were asking me or asking my colleagues in my department, how can I improve the design of the part to make it printable? And always it was a phone call, long meetings, and with the tool of 3D Spark, they can do this job by themselves. So it means they make a modification, they can upload the part into the system, they get one approach, it is red, it is green, you can go in this direction, and this is giving us the opportunity to speed our development process, to save time. You can see here 50% of the time is saving. We have out saving also the accuracy of the results that we have, and at the end of the day, in this kind of the bale block, I can put some figures. We reduce around about 35% of the weight of the bale block, and then we have more powerful performance of this bale block. So after this analysis, after this use case, in this setup, starting using 3D Spark tool within ZF, we go further. Parallel to these activities, we started to set up a new project, a funding project. This funding project is supported from the German government. It's a BMBWK project. The name is Nexamo. That is, you can see here out the partner that we have. We have different kind of technologies like SLM solutions, like Erlanger, Erlas. We have different kind of support from different companies like Fraunhofer IAPT in Hamburg, Imprintech, and IMSite. Most of the people are here these days in Frankfurt. And then in this project, we want the idea to go further with the 3D printing process and then to build up a new environment for 3D printing process. What is a new environment for the 3D printing process? We are thinking how to bring this technology in the next steps, and our goal is to build up a matrix production. What is a matrix production? In this matrix production, the idea is to put all these machines together in one hall, to have the possibility to be flexible, to be modular, to increase the amount of devices according to the demands that we have from our customers, and at the end of the day, to build up this kind of new environment to use by using cobots, by using AGVs, to set up the possibility to adapt our demands from our customers to the current situation. What we are doing, you can see here, our strategy, our mission is to bring this 3D printing technology and the other process like finishing, like quality assurance to the next level, setting up this matrix production concept. We are going to get more flexibility, more adaptability, and more resilience in our production lines by bringing flexible, intralogistic, modular design, adjusting the demands that we have in the different machines, intelligent production control, and of course, multi-technology processes. It's not in this production line, in the first focus, we are focused on material like aluminum, but in the future, it is possible to set up another plastic, another technologies within this line. Our goals are to short the production times, to use the capabilities for each process steps in a better way, and then to increase the efficiency and with a high level of automation. Our internal application areas for this matrix production line is production of prototype, of course. That's most known for additive manufacturing technologies. To build up one ecosystem, one possibility to produce a small volumina of parts in a metal way, to produce our internal spare parts for machine. That is a use case that we are using within ZF with a good benefit. So by printing the parts that are broken in the production line, we can reduce the downtime of the machines and increase our OEE. And then, of course, another use case is aftermarket. Aftermarket is a good use case because you have in short volumina, you have the possibility to use the 3D printing technology in this stuff. What we are going to do in the project, I am going to put in the next slide. To set up this matrix production, we define 5 areas for research and development. And the first one, we are going to set up what is matrix production, what is needed for this matrix production for the additive manufacturing for the next generation. In the second area, we want to focus on the intralogistics, how the machines should connect to each other, how to work with the cobots, how to work with AGVs, AMRs. And in the third area is everything that you can build in the physical way. You need today a digital twin. You need to build up one IT system. That is what we are together again with Ruben. And in the software, how to coordinate this production planning, how to coordinate this assessment of the part, the production of the part. And later on, the research for 4 and 5 is focused on 3D printing technology by increasing and optimizing the additive manufacturing technologies by using new materials and bringing out to the production's demands from ZF. As you can see here, the idea is one person within ZF has a need to print, for example, a control arm like here. He's ordering the part. We have the assessment tool. We'll see in the next slide. He can realize is the part printable or not. One is printable. We can go into the order management tool into our machine production planning, and then the machine is going to describe what is the best process steps to go through to get the final part. And in this idea, we want to consider the modularity and the status of the machines. If one machine is broken, it is possible to replan in lifetime to readapt the route and then to readapt the production of this part. It's like I like to compare with a navigation system. You go from Frankfurt to Berlin, for example. You navigate. You put in your auto the coordinates from Berlin, and if you have a traffic jam on the way, it is possible to readjust the route in the best way to get the target of Berlin in the most effective time. This project is running right now within ZF. We are going to finish the project till June 2026. In 2026, we will have the production line set it up in Friedrichshafen, our headquarters. And then, to build up this product into reality, we need our system landscape for IT. I hope it's coming. No, take some time. Not my problem, sorry. Talking about this, okay, now. And then, this is the idea behind to prepare and to work with this production. We are going to implement the 3D Spark tool. In the 3D Spark tool, we are going to take care about the design for manufacturing. So to have one assurance of the manufacturing of the parts, to have a first cost evaluation of the parts, to have a technology comparison, auto quotation, what Ruben was showing us. And then later on, with this process test, we are going to put this information together in our system to plan our production, to simulate our production by using these AGVs, by using these cobots, and this optimizes capacities of the machines, and later on to go into the production. That is the idea behind that we want to build up in the next AMO project, and that is what we are focused on for the next 2 years, let's say. And that is from my side, the last slide. Thank you very much for the opportunity to present this project together, working together with Ruben. It was a nice work. It will be nicer now with the next AMO project. And then I am happy to try to bring this additive manufacturing technology to the next step together with Ruben, with 3D Spark. And then I am, think that this matrix production will be the future for ZF and for other companies to go in this direction. Thank you.
Thank you very much, both. And that brings us to the end of this session. So we have a half hour now that you can approach these two gentlemen to ask them your questions, or you might even just get across to 12.1 to the 3D Spark booth in that time.
Yes, thank you.
Gents, thank you very much.
Thank you.